Okay. So, of course, when you create a model, okay, you want to train the model and evaluate the model, okay, and but this process sometimes can take a long time, okay, and so it is very important to know how to save or restore a model, okay. So this here, for example, when you create a model, okay, after you compile and feed the model, you can use model.save, okay, and specify the name of the file name, okay, to save the model into, okay, and the Keras will save the model using which is called like I think like you will use HDF5 format to save the model architecture and the value for all the model parameters. So obviously you can also use like Keras.models.load model, okay, to restore the model from the saved file back to your model object, okay. So but keep in mind, okay, these things work for the sequential, the model that is created by either sequential API or functional API. But for subclassing API, if you use subclassing API, unfortunately, it's more complicated, okay, because as I said, okay, the model architecture, okay, in the model that is created by the subclassing API is not, that easy to be obtained by Keras. So well, it is much more difficult to save and store a model that is created by subclassing API. That is also one, and this is also another reason, okay. If you are not using a dynamic model, you should not use a subclassing API, okay? And it is, when you create a model, it is very common that the model training takes hours, okay? To be honest, like in my lab, like sometimes, I mean, when we work on a model, okay, the model, each training can last for like not necessarily, not only, but like a couple of hours, but like a couple of days. Okay, it could be that long. Okay, so yeah, this part, I mean, you can, if you use model subclassing, okay, you can use save weights and load weights, okay, to at least save and restore the model parameters. Okay, but you need to do all this by yourself. Okay, so this is not as convenient as like a model created by functional API or sequential API. Okay, so if your model training takes like several hours or even days. Okay, so what do we do? Okay, sometimes we want, because I'm not sure. I mean, have you ever had the experience? But you guys are pretty young. I mean, so. When I was in United States, okay, I mean, there's one occasion, okay, it took me like, almost a week to work on a project, okay. I still remember that that class is computer graphics. Okay, I'm not sure if you know about this, because does our department offer this class, computer graphics? Yes, but I'm not sure like the computer graphics you guys are learning today, okay, is the same as the one that I learned like back to, that was like 1994, 1993 or 1994. Okay, that was a long time ago. I think it was before you guys were born, right? Right. Yeah. So I'm too old. Yeah. You don't need to remind me. Yeah. So yeah. So basically, like we write, in computer graphics, I mean, that's the nature of the class. I mean, you just need to write a lot of code, okay, for almost a week. And just before the due day, okay, the computer crashed. Okay, computer crashed. So all my data files are gone. Okay, so what can I say? So yeah, of course I got a very poor grade. Okay, but the important thing to tell you is that, okay, when your model training takes hours or even days, okay, the most important thing is don't trust your computer. Okay, the computer can crash. Very often, like, especially if you are running Windows. So the important thing is that, okay, we have a way, okay, to keep the intermediate result of the model training. It's called callbacks, okay, or checkpoints, okay. Checkpoint is like when you are doing something, you save the intermediate results, okay. We call that checkpoint. So in the case, like, if something catastrophic happened, we call that rollback. You can restore the latest, results. So this in Keras, it is called callbacks. Okay, so this is okay. So you can use a validation set, okay, during training, right? We use that all the time. So you can set save best only equal to true. If you set up the callback like correctly with this argument like that, then it only saves the model with the best validation result during training. So which is very nice. Okay. So let me show you like the example. Okay. So first you create checkpoint. Okay. CB just abbreviation as for the callback. Okay. So this is actually an object. Okay. The model checkpoint object, which is a callback object. Okay. And you provide the name of the file that you want to save your the intermediate result to. Okay. And you specify save best only to be true. Okay. So that it will save the best model that you have so far during the training. So here, okay, for example, you can start using the model fit to train your model. Okay. So here the epoch is only 10. Okay. But if you set this thing, okay, like that, then you can. It's okay to have a much larger epochs, okay, because like eventually, okay, this place is going to keep like a much better, the best model that you can have anyway, okay. So after the training, okay, after you specify this, okay, of course you also provide the callbacks, okay, which is this checkpoint callback, and then, okay, you just let the computer run and you go to bed, okay. So next morning when you wake up, okay, the only line you need to run is this line, okay. You just load the model from this place, okay, back to the model, and you are going to have like the model with the best performance, okay. So which is nice, right? So so remember the early stopping idea that I talked about like last chapter, right? So this is somewhat similar to that, right? But the only difference is that, okay, it doesn't stop, right? In the early stopping, like for example, like when the validation result getting worse and worse, you are going to stop the training, right? That is why we call it early stop, right? So yes, we can actually use the callback to implement the early stopping, and this is actually the more standard way in deep learning to implement the early stop. So it's like this, okay? So you can we can have like a, you know, early stopping callback object, okay? And here, okay, we set the patience to be 10. Restore best wait to be true. Okay, this is the same as like what we just mentioned earlier. So as for this patience, this patience just means like, okay, say we already hit this the lowest like validation loss. Okay, if it doesn't go any lower than this one, after the next 10 iterations, then the training will be killed. The training will stop. Okay, so this patience basically control like how many additional iteration you want to wait to see if because as I say, like the validation loss can fluctuate, right? So you want to wait for a few more iteration to see if it eventually go down, right? So this 10 just means you want to wait for the 10 more iterations to see if your validation will actually go lower than what it has been recorded, I mean, to be the lowest. Okay, so if that happens, okay, you are going to obviously, you know, save the best model, you know, replace the best model with the even better one, and then recount that 10 times patience. Okay, so with that, you can see we set epoch to be 100. You can set what, you know, very big epoch number anyway, because it doesn't matter. Most of the time, it's not going to run this long anyway. So because it's going to, the training will stop. Okay, you know, because of the early stopping anyway. Okay. So you specify the checkpoint callback and early stopping callback. I mean, both of them. And once you are done, okay, because you set up this early stopping callback, so the model will automatically be restored to the best one. So this is like how the early stopping is implemented in deep learning, okay? So I think I already, mentioned about the idea here. But there are many other callbacks available, okay, in Keras.callbacks package. So this is like, you know, if you want some the Keras to do some side works for you, okay, at a specific moment, you can check out like some callbacks that that sometimes they can help you a lot. So, for example, if you need extra control, okay, you can even create your own custom callbacks. This is an example, okay. How we can do a custom callback. This custom callback, okay, is just going to the print the value for the training ratio, okay, for you, okay, at end of each epoch, okay. So what you can do is you subclass the callback, okay. You call this a print val train ratio callback, okay. And here you define, okay, on epoch end. So this is at the end of the epoch, okay. So you want to print this value, okay. This value, sometimes can help you to observe like the training progress, okay, because it print out the validation loss for you, okay, pretty much. But so you can see that this statement will be executed, okay. If you include this callback, this statement will be executed at the end of the epoch, right? Obviously. So you may ask, so what occasion, other than end of the epoch, in what other occasion can I have my statements executed? Actually, there are so many, different places you can run your code. Okay, for example, on train begin, on train end, that's at the beginning of training or at the end of training, on epoch begin, on epoch end, on batch begin, on batch end, you know. So there are so many places you can do these things. Okay, so this allows you to have the control of many things to do at a specific time. Okay, when you are training the model. Okay. So next, probably 20 slides. Okay, is about TensorBoard. Okay, what is TensorBoard? The TensorBoard is a tool. Okay, this is a visualization tool that help you to visualize your model. In addition to that, you can check like a model architecture, model like a weight. For different layers. You can even check like the learning curve. Okay, when you train the model. Okay, it actually draw all those visual results dynamically. Okay, when you're doing the training, it will generate those visualization results. So it's very nice tool to have. It's a very nice tool to have. But on the other hand, okay, I kind of feel like this is kind of like some extra tool, okay, for you. Which you don't necessarily need to use it. Okay, if you know it, great. If you don't know about it, you can still write your program very well. Okay, but obviously this is a good tool to know. So if you want to have your model to be visualized, okay, then you import this and provide this use this code, okay, because you need to specify, okay, the place where you store those intermediate results so that the TensorBoard can draw the visual result based on this text results. Okay, so for example, okay, after you specify, the directory. Okay, so if you get wrong log directory, it will give you like this. Now this is basically specified like this is a run, okay, of the model. At a certain time, okay. So with that, okay, first you have this function defined, and then okay, you create a TensorBoard callback, and you provide that function as an argument of this object, so that you will save the intermediate result, okay, into the appropriate place, okay, and then when you do the model fitting, okay, you provide this callback, okay. So after that, you can use the TensorBoard to visualize the result, okay, and so here, okay, it shows you like the architecture, the structure, okay, of like the location that the intermediate result is saved. You can see like at the different run, at the different training instance, okay, all these things will be saved, okay, including the training as well as the validation results, okay, and here it shows another training, okay, and you have additional results here. So it's going to save a lot of like this intermediate stuff, okay, and once you have those intermediate results, okay, even during training, okay, you can file the TensorBoard. TensorBoard is actually a program, okay, that use like a web service to provide the visual result. Okay, so it's kind of like Jupyter. Yeah, Jupyter is also like that, right? Jupyter is actually like it provides the service through the web, like interface. Same thing for the TensorBoard. So you run the TensorBoard, it will tell you, okay, TensorBoard, okay, it is at this, basically this is localhost, okay, and the 606 port, okay, and then you can have your browser pointing to this website and to observe like the visual result. And sorry, here, okay. So and also if you are in Jupyter, okay, you can also use where is it? Yeah, in the Jupyter you can also initiate the TensorBoard by typing these statements. Okay, so this is like how you start the TensorBoard, and the most important thing I want to show you is, so this is like what the TensorBoard looks like. So it's a very fancy tool, and you can see you can even like have some control over like the visual result you wanted to demonstrate. And yeah, and this one obviously shows like the learning curve, okay. And I just want to tell you, okay, this thing is so cool that it actually, while you are training, okay, this thing can collect the result from the training and draw it dynamically. You don't need to wait for the end of the training to draw this. No, you can just start this TensorBoard and observe this learning curve, like to create like on the fly. Okay, so it's very nice. Obviously, you can also, if you already have some model that was trained previously already, you can also like select a certain log to show like the learning curve. So it's an interactive visualization tool. Okay, so so you can also visualize the whole graph. Okay, the learning weights. Okay, everything. Okay, from the TensorBoard. Okay, and TensorFlow also offers a low-level API. Okay, in tf.summary package. So this one, okay, creates a summary writer, okay, which will write a, use the create file writer function, use it to write a context to log scatter, okay, histogram, image, audio, text, okay. So you can, all this you can, basically visualize using TensorBoard. So here I just provide a code for you, but to be honest with you, like I'm not that much of a big fan for visualization tool, even though I know it's a convenient tool to have. Okay, but you guys can try. Okay, but I kind of feel like as long as I get like those like training accuracy, training loss, and validation accuracy, validation loss in text, I'll be satisfied. Okay, most of the time. Okay, but obviously the visual tool is a good one to have. Okay. So in summary, okay, so this TensorBoard is a nice stuff to know about, but so you can invest some time to get to understand it better, and also we have learned where a neural network comes from, and what is a multi-layer perceptron, and how you can use it for, okay, such as classification, regression, and how to use sequential API, functional API, subclassing API, all this. And we also talk about how to use, for example, like how to save the model, how to use checkpoint, how to do the early stopping, and in addition to those things, the TensorBoard, okay. And you know, but we obviously have many hyperparameters we can tune. Okay, when you train a model. Okay, so this actually has something to do with you know, the performance of the model. I mean, because I just got a student asking me like, you know, oh, my performance, my MLP performance is not as good. Okay, so the first suggestion I will tell you is basically like there are many hyperparameters that you can tune, okay, to get a better performance. You know, there are other things, but you know, we can start from the hyperparameter tuning. Okay, so what are hyperparameters? Okay, for example, okay, then you know the hyperparameters, I mean, include, okay, for example, the number of layers, number of neurons, I mean, in each layer, and the type of activation function, and the weight initialization. They are. I mean, right now, I mean, a lot of this we really haven't talked about that in depth, no, and other than those, for example, like learning rate, okay, or like optimizer. So far, the only optimizer you are familiar with perhaps is like SGD, right? So there are other optimizers out there that can help you to get a much better performance. So you know, what hyperparameter value should you use? Okay, I mean, so this is, I mean, you know, we want to talk a little bit about this, but we will go into much deeper on this topic in next chapter. Okay, but now we just, you know, a quick, like try to give you a quick overview of this hyperparameter selection. Okay. Of course, if you are trying to just like okay, just want to find like a good combination of those hyperparameters, one way to do it is to use grid search. Okay, grid search basically just, you know, grid search, right? Basically like just, for example, like okay, you want like to see how many layers is good. Just 1, 2, 3, 4. Okay, try all the four combination, four types. And if each layer you don't know how many neurons, okay, you can try 100, 200, 300. Okay, so you have 3 options for number of neurons for each layer, and you have 4 options for the number of layers, right? So 3 times 4, 12. Okay, so this is grid, you know, grid search. Pretty much grid search is like that. Okay, and but the grid search, obviously, when the number of parameters increases, okay, obviously, because you are going to have many options to try, many combinations to try, right? So maybe, because for each combination it takes time to train the model, so maybe it's not an ideal approach. So another approach is to use a randomized search. Randomized search is something like okay, you just randomly determine a combination, and if that combination gives you a good result, try to find like a combination near that the other combination near that combination. Okay, so that's the basic idea of randomized search. Okay, so here, I mean, we use like you know, give you like, this is like a you know, we can, you know, build what is that? I mean, we call it like a grid search CV or randomized search CV. Okay, to explore hyperparameter space. So randomized search normally will give you a better result in a shorter period of time, but you don't have, you cannot guarantee that that is the best value. Grid search, because it pretty much goes through all the combinations. I shouldn't say all the combinations, because maybe you just try like a 100 neuron, 200 neuron, 300 neuron. So it doesn't, it's not like a 100, 101, 102, right? So it doesn't give you like a all combination, but it gives you like a most of the combinations. So you are more confident that the grid search result, the best one, is pretty good. But for the randomized search, it doesn't try all the combinations. So you spend shorter period of time to explore the search space, but it normally give you a better, a very decent result already. So this one just you can follow this example to try to use because you define a model, define a build